We are live now.
Okay, are we live?
Okay, we can start now. Perfect. So, thank you everyone for tuning in and welcome to the AEZ Boost Hackathon. We aim to focus on pushing builders to explore and develop new ideas on Cosmos Hub. So, yeah, I think this is a great opportunity for all the builders with prizes up for grab worth 100K dollars. With that being said, I'm extremely excited to kick off the first workshop with Faku from Binary Builders, which is on Introduction to Building on Cosmos SDK modules. Faku, please feel free to share your opening thoughts and then take the builders through the presentation and the workshop for today.
Awesome. Welcome, everyone. So, well, I hope you can get started building modules out of this workshop and, yeah, and hopefully win some prizes. Well, first of all, I'm Facundo. I'm from Binary Builders. I work in the Cosmos SDK team. And we are going to go through the basics and not so basics about building a Cosmos SDK module using Go. So, well, first of all, let's do an overview of what a module has, because it's a bunch of different things that every module has. And first of all, we have messages, which is basically transactions. So every time you talk with, I don't know, you do a send of tokens, you are actually executing a message. And you have queries because you want to, for example, know the balance of your account. You have params because there are some predefined stuff that you want to be able to change, for example, through a governance proposal. You have storage because you want to be able to store some data from your module. You want to store it on disk. And then optionally, you have begin and end block, which are two parts of the module that get executed at the beginning or at the end of a block. Today, we're going to be using end block. And lastly, something you can do with a module is to communicate with other modules. This is super important because you want to be able, for example, to do send tokens. You want to be able to query another module's state. Like, for example, I don't know, you want to see the validators right now. Well, you can actually do that if you communicate to the staging module. So what we'll build is a very basic rock, paper, scissors game using the commit reveal scheme. So we'll have a player that's going to create a game, and it's going to start with its own commit. And then another player can join by sending its own commit. Then we'll go through a reveal phase. And finally, the winner will take the prize, or if there's a draw, we are going to return the entry fee to both players. How the commit reveal scheme, we're going to do a quick recap. So basically, you create a hash, which is going to be your commit of your choice. So here in this example, it could be paper, and you add a salt. So basically, you do a hash of that and send that to the chain. The same, it's going to be done by the other player. And then once both players have committed, you go through a reveal phase in which each player will inform the chain of their action move and the salt. And then on chain, you can check and you can verify if that combination of the move plus the salt actually gives you the correct commit, and that's how you know who won the game. A couple of rules we are going to add. It's a commit timeout. So if a player creates a game and it goes too long without any other playing joining, you should cancel the game and return the entry fee. The rebuild timeout, it's pretty much the same, but if two players committed and then one of them reveals and then the other player doesn't reveal for any reason, after a while, you choose a winner by default. So let's start with the setup. We are going to use two main parts, which is the Cosmos module template. I also work at Cosmos. I'm part of the team, and we are building a bunch of things. We are soon to launch, and one of the things we developed is this module template, which is super useful if you want to get started with your own module. It has a bunch of boilerplate code, some useful scripts, so I recommend you to look into it. And then also we have Julian's chain minimal, so we can actually import our module into it and then run it, so we can quickly check out what we are building without having to write tests, which is going to be left out of this workshop for now. And then, of course, the usual Git, Docker, and that stuff. So first of all, we are going to clone both repos. I did it in a single directory for ease of use. And we are going to run a rename script that the example repo has. And then we are going to import our module into the chain. And then we are just going to run the chain pretty quickly just to make sure everything works correctly. So we are going to get at that. So, well, this is the basic. It's just as I clone it, no changes were done. So you have up here the rename script open, and it tells you basically how to use it. So you can do what I have here. What I'm going to name my my module RPS, rock, paper, scissors, pretty simple, and I can just run it. Remember to have Docker running when you do this because it uses Docker. So it's going to run a bunch of scripts, and then you have your module ready to go. So it did a bunch of renaming and in all the files, so you are ready to go with your module. So now we can go into chain minimal. And here it's a bit more complicated than that. So first of all, we are going to add a replace command here. So we tell it to actually look for this module locally. So in the outside folder, we just do that. And then to add it, we can go ahead and here we have enough config.go. We have all the configuration for our chain. So we just basically need to add our stuff here. I can actually do that right now. So hopefully it's big enough. So first of all, you're going to be importing your some packages from your module. And then later we are going to add it here. So because we are going to have some tokens coming into our module, well, we want to create a module account. If you don't do this and you try to send tokens to your module account, it will fail telling you that that account doesn't exist. And then we go through here and we add it in the init genesis because all modules need to have an init genesis. And then down below, we added just like any other module, we added here, just put the name and the module configuration of your module. So now we have a command ready to use in chain minimal. And we do make install, and you'll see it takes a little while to build on my machine, but you should see it succeeding to install. There we go. Then we go making it, and that creates the Genesis file for us, and it does it in the home directory under this directory .minid, and then we can just start our chain with minid start, and you can see now that we are going to start creating blocks right away. Perfect. So we have the very basic setup ready to go. So we run the chain and we see that everything is running correctly. And then now we start building the actual module. So we're going to define the messages and types queries for our module. So the messages are going to be the ones that like form a transaction. And then if you want to query anything, you will use another message. And all of this is done in protobuf. Oh yeah, and there's also some types that we need to generate also to store in disk. Then we are going to run the proto generation script, which is also included in the example repo. And then we are going to do the basic implementation, just the function signatures, so the compiler is happy. Then we are going to do a little thing in the codec that we need to add the messages there. And then we are going to ensure, of course, that the chain builds. And let's go there. So let's change here. And we are going to go to the proto directory. So, oops. Okay, wait. I had it here. Let's discard all these changes. There we go. Okay. Now we go to the proto directory, and we have 3 files. So we have the query, the transaction, and the types proto. So on types right now, we only have the params, which are going to be the params of our module. And for that, we are going to add a commit timeout and a reveal timeout, which we talked about previously. Let's add that. And then I'm going to add a gain message, a move commit message, and a move reveal message. For brevity's sake, I'm going to just copy them from the finalize project, and let's go through them pretty quickly. So basically, wait, there we go. Let me close this. So here, what we have is the game message. It's going to have an ID, which is not really necessary, but we'll see later that it's going to come handy. We are going to have the entry fee, which is going to be a coin. We have this custom type in Cosmos. And then we are going to define the commit timeout and the reveal timeout as timestamps. Then we are going to have the move commit. So basically, what the user is going to send whenever it wants to play. So it's going to send a commit, and we'll know the time it was created. This is also optional. And then finally, the move reveal, we are going to say which is our move and what was the salt we used to hash and get our commit. So after this, we have the query. And here we have an example from the example repo. And we are going to remove this because we are not going to use it. And also, we are not going to use the request and response for it. And we are going to add 2 queries that we are going to use. Here they are. So we are going to have the games a query and the count query. These queries are, this one is just going to return a list of all the games that are ongoing. And the count, it's going to tell me the historical amount of games that it has been. So I'm going to paste the entire thing here. And you can see that the query games request doesn't have anything. In the future, you can add pagination here. We are going to skip that for now. And the response is just repeated of game. Then for count, we are just going to return the count, and we are not going to take any input there. Then for messages, for the transactions, we are gonna have a couple more. So we are gonna have three, actually four, counting the update params, RPCs. So we're gonna have the new game, the commit game, and reveal move. So these are all the things we need for our game right now. So we can go pretty quickly over the messages. So the new game, so it has a couple of, every message needs to have some options from Cosmos. So for example, you need to define which field contains the signer's address, and then the amino name just to make it compatible with amino JSON signing, which is used by it's used by Ledger, for example. Then we define the player, so who's going to be starting the game, the commit, and also the entry fee. And it's going to return the game ID. Then we have the commit move, again, the same options, the player, and we say which game we want to be part of. And we also have the commit. And then finally, we have the reveal move. So again, we have the player, the game ID, the move, and the salt. So that's basically it. And once you have all of these defined, actually you don't really need to have them all predefined, but you can go back and forth in development. So you add something and you now generate the protos, and then you go back and remove and regenerate the protos and stuff like that. So the Cosmos temporary repo makes it pretty easy for us. So we can make protogen, and it's gonna create all of this stuff for us, which is pretty cool. So you can see we have all of these generated Go files. And now we are going to see that in the Keeper, we are going to have a bunch of issues. So while the tests, we are going to ignore them right now, but we are going to comment all of these for now. But for example, here in message server, so you can see here that we have increment counter, which was from the example. We're going to remove this. And here you see that it's not compatible because we're missing some methods. So for this, you can do it manually, or if you have a good code editor, you can just go here and implement this. And it's going to implement all the handlers. They're going to be just empty handlers, but it's going to make the compiler happy. And then the same you need to do for the query. The query here. We are going to remove this one because it was from the example. And then you can just do the exact same thing, implement, and that's it. So now we can try to launch OWL, and then on codec, we almost forgot about it. So here you need to register all your messages, and I'm gonna just do this so I can show you the finished thing. And as you can see here, I have all my messages registered here. So they are ready to use by Cosmos. You need to register them here. So then on signing and signature verification, the chain actually knows how to decode and encode these messages. And now we can go back to the chain and we can do make install to make sure everything runs as expected. Takes a little while. There you go. So everything builds. So we can go over to the next step already. So the next step will be actually implementing storage and the business logic. We are going to do just part of it, and then we can go. I'm going to show you how it looks finalized. So we're going to use the collections package, which is like an iteration over how we used to do storage on the Cosmos SDK. I think it's a pretty cool advancement in this matter. So with collections, you can define collections, and it's gonna handle for you the marshalling and unmarshalling of objects to bytes and from bytes. So it's super useful. And then you have a couple of helpers that also makes the dev lives easier. And then, well, we are going to define our collections, and finally, we are going to implement some business logic. So to define a collection, you first need to go, oops, not this one here. You first need to go to your keys. So you need to, for every collection that you're going to have, you need to define keys. You need to define prefixes. So everything you do, and all of these prefixes must be unique inside your own module. So you can repeat the one if there's another module using it, but as long as you don't use it in your same module, you'll be fine. So you're gonna have just 4 of them. So, well, actually 5. So we are going to have the game ID key. So there's going to be an auto increment or sequence, how it's called in collections. The games key, so the actual collection that holds every game. And then we are going to have one for commits and one for reveals. Well, once we have this, we can go into the keeper. And you see here we already have an issue because we are removing stuff that was in the example. So we are gonna get started with the collections sequence. The sequence is basically what if you are into the SQL word, you know it as the auto increment. So basically, it's how we get the game ID. So we're gonna do a collections sequence. That's it. We are gonna do games, which is gonna be a map. So this is something that it's pretty cool from collections. You can define collections and maps, and you say, okay, this is the key, and this is my value. And then we are gonna define the move commits and the move reveals. So this is a bit more complex because you want to have commits. Their key, we want to have it to be the game ID plus the player address. So we can use both of those to identify who did this commit. For this, we're going to use something called a pair key, which is included in collections. And we are going to do uint 64, just like the game ID. And we are going to use a byte slice, which is going to be our user's address. And as an object, yeah, a move commit, and the autocomplete value right. And yeah, we can let the autocomplete do the rest for us here. So we are going to define move reveals in the exact same way. The only difference is the value that we are going to store. Once we have them defined in the keeper, we are going to go to the new keeper function, which is the one that initializes it. So we're going to do the game ID first. And I think it got it right. Yeah, perfect. So it just used the right initialization function for each one of them. So we can do this. Well, the difference here is that we need to pass a key codec and a value codec. The key codec here will be uint64 key, right? And then for move commits, the autocomplete, it's not doing a good job now, but collections new map, and this is all the same. Move commit key, this is fine. Now we need to do the collections key codec for this, that it's a pair. So for a pair, it's a bit different, but we already have it solved with collections. So we do collections pair key codec. And we should say, hey, I have an uint64 and a byte slice. And then we pass each one of those separately. So collections.uint64 key and collections, bytes key, perfect. And then the codec for the value, it's pretty simple. Then for move reveals, it's going to be the same. Let's check if it's doing a good job, the autocomplete. I think so. So we can use that. And that's pretty much it. So we already have the collections set up, and now we can get started with the actual implementation of our messages. So we're going to implement just one, and then we are going to skip to the finalized product, like in a cooking show. So first of all, we are going to have, let's see. Oh, well, we need to make this available for us. And message. So I'm going to paste this here that I had ready. So first of all, we need to check if the entry fee is 0, because we don't allow that. And we are going to create a game using the collections that we created before. So the game ID, which is a sequence, we just do next and we get an ID. If a good thing to note about the Cosmos SDK is that if something fails, as long as you return an error, the changes made by this transaction, it's going to be reverted. So you don't have to worry about it. It's just discarded. So if you did a bunch of, for example, you incremented the game ID and then something failed, well, don't worry, that's going to be removed from storage. So, well, we are going to continue here, and we are going to create the actual game. And we got here params because we need to set the commit timeout, and we have it defined in the params. So we are going to do set the ID, we are going to set the entry fee, and for commit timeout, we need to have a time. For this, we're going to use a little trick, which is unwrapping the context to get the block time. Let's see if I can get it to, okay, no, we need to import it manually, but this is just the types, from the Cosmos SDK. And unknown field. Oh, yep. So commit timeout, and we're gonna do SDK block time, and we are gonna almost there. We're gonna add the timeout because it's defined in seconds. We're just gonna do time seconds, time, perfect, time duration, parents, commit timeout. Perfect. And then we are going to set it in using collections also. So we are going to do exactly this. So we're going to take games from a keeper and set our game. We're going to return an error if that happened. And lastly, we are going to create our commit. So let's do this. The commit, it's basically including the message, and just because we can, we're going to decreate that, which is totally unnecessary unless you're using it. And then finally, we are going to add it to our collection. So we're going to do move commits, set context, and then here we have a collection key pair. So we need to do collections dot join, and you have to pass the two keys. So here we have, first of all, the game ID and the player ID address. Perfect. And then we just pass the commit. Again, we check if there are any errors, and if everything went fine, we should get a response with the game ID. So, well, that's basically it for creating the message handlers. And we are going to jump until the end of this. So perfect. We have the new game defined just like before. We have the commit move, which is basically the same, with the only difference that we check for the commit timeout because it's an already existing game. And we are going to have also the reveal move. And the reveal move is pretty much the same. We just check if we are in the game, and if we are in the game and the reveal timeout hasn't passed, we are allowed to store our reveal. So once we store our reveal, we actually, before we store the reveal, we check if the commit that we had already stored matches our move, the move that we are revealing. And it's just by doing a simple comparison between the two commits. And then we finally store the reveal. And that's pretty much it for transactions. And then, well, I have implemented this later, but we'll have the query server later. So now we can just go back to chain minimal and also again make install to make sure everything works and builds. Takes a while. Okay, there we go. Perfect. So now we're going to go to this other very important part, which is where we define the CLI commands for our app, which is the first way you are going to be able to talk with your module. So first of all, we are going to talk a little about auto CLI. So auto CLI or client V2, what it I think it was used to be called like that. Auto CLI makes our lives easier when defining CLI, because before you would have to define a bunch of things manually. Nowadays, we want to move on to a more automatized way of doing this. So basically, we use the protobuf definitions to generate the CLI commands. You can still do some custom things, and we are going to do that in a bit. When we define the queries and the transaction handlers. And then finally, I'm going to show you how they look in the actual binary. So let's do this, and I'm going to go back to the app. And well, first of all, I'm going to be opening the auto CLI file that we have here, that it has some stuff already from the example, and then we are going to remove the counter and this service here. We're going to leave this open because the ones that we want to define are all custom. So here we are going to have, as you remember, we have only two queries, and which is the games list and the count. So we are going to define those here, which is basically just this. You just paste the RPC method how it's called in the protobuf definition, how you use it, so the actual command, and just a small description. You can also define a bunch of other stuff, like an example, a longer explanation, aliases, well, mark it as deprecated if you want. Do a bunch of other stuff with here with flags and stuff like that, but we are going to keep with the basics. So once we have this, we need to define our transactions commands. And for that, I'm gonna just skip until the step that I have that ready. There we go. I think we are here. Okay. So for this, we are defining getTX CMD on our app module. So, and here in the example repo, it's under module in module.go. And getTX CMD, it's how the SDK is going to look for our custom module, transaction commands. So we are going to define like a root command, and then we are going to add our commands into it. So let's take a look into new game CMD, for example. It's just a cover command, so you need to define it as one. So you should say, okay, this is the use of it. You have these two arguments. This is how, this is what it does. And then we do some stuff here that it's actually from the SDK. So this is going to be probably a copy paste for now in all of your commands. So you basically get the client context from the command, and then you get the user sending it. Then you get the arguments, you do a validation of the arguments. We calculate the salt, which is needed for our commit. We actually calculate the commit using just this simple function that does a SHA-256 and hex encodes it. And then finally, we create the message new game and we broadcast it onto our chain. Here you can see that we are printing the salt because you're going to need it in the reveal stage for sure, of course. And then the same we did for the commit move, which is pretty much the same. And the reveal move also, again, the same. We just take the arguments, assemble a message, and just broadcast that message. Then all the signature and stuff like that, it's going to be handled by the SDK. So you just have to do the stuff that it's about your module, right? So we can go already to chain minimal, do a make install, and we should see that it works just fine. Okay, so we can actually go here, and if we do mini DQ, we can see all the modules that we have, and between all of them, we have RPS, which is our module, the module that we are building right now. And we can do query RPS, and you'll see that we can see counts and games and params, which is the three queries that we enabled. And also we can do the same for transactions. So we can see here that we can do a commit move, a new game, or reveal move. So that's pretty much it about the how we talk with our app. So, and we can actually go ahead and create our first game. For this, we are gonna do make init. So we create the Genesis JSON. I'm gonna paste from here the default values for our params. Here, if you need to find it inside the Genesis.json, and you can put here any defaults you want to start the chain with. So I'm going to use 60 seconds for commit and 60 seconds for timeout. And now we just start our chain. Perfect. And we are generating blocks, and we can actually go here. And I have some helpers here, so I don't have to write the whole thing. So I'm going to start a new game. So Alice is going to bet 900 mini, and it's going to play rock. So we can just broadcast it, and we'll get some info about the broadcast of our transaction, and we'll get the salt that we'll need for the reveal stage, and we are going to take note of it. And then we can actually do RPS games, and we can see that we have a game here that it's going to be timeouting pretty soon. So we want to move fast, and we are going to play paper with Bob. So Bob, it's going to play paper. Now we also got the salt, and we are going to use it in his reveal too. Now we can already start revealing, and we'll do this, and we can actually check for any errors. So we can do minidqtx, and this is from the Cosmos SDK, and you can see a bunch of information about your transaction. So you can see here the code is 0, so everything worked just fine. And we can also double check in the games that now we already have a reveal timeout. Before we didn't have it because no one had revealed, and because no one revealed, the reveal timeout didn't start. So we are going to wait a couple of seconds just to see it fail when we try to reveal using Bob. So we're going to wait. There we go. I think it should be already there. So just wait a couple of seconds more just in case. And now we are going to try to reveal our move with Bob, and he's doing it after the reveal timeout, so we should get an error. And we commit. Here you get code 0, but this is just like it allows you to send a transaction, and then you need to check the result using this. And we are gonna check it, and there we go. So we get an error. So you get, if you go up here, you see code 1, so it's a failure, and you get in the logs that reveal timeout has passed. That's perfectly fine. That's what we wanted to see. So now that we see that our app works fine, we can move on with the next step, which will be communicated with another module. So to communicate with another module, we are going to use what it's called an expected keeper. So it's basically an interface that implements a part of another module's interface, in this case, bank. And the ping checked, which is one of the libraries that we use in the Cosmos SDK, it's gonna get us the right module for us with us. So it's gonna look for the module that implements the interface that we want to use. So, well, and once we have that, we can do transfers. So we are gonna modify our code. So when we create a game or commit, we are actually sending the entry fee to the module, and then we need to pay it out also using this keeper. So I'm going to go back to my module, and I'm going to go to message server. And okay, so here we are going to create a new, actually we are going to create a new folder, expected keepers, and inside it a new file, expected keepers.go. Perfect. Just to save some time, I have it right here. There we go. So we only need two functions from the bank keeper, which are send coins from account to module and send coins from module to account. Perfect. so then in the keeper, we need to, actually, we first need to go to the being checked, our being checked file down here. So we have the module inputs, and we can say, hey, we are telling the being checked that we need the bank keeper. So hey, the being checked, give me the bank keeper. There we go. And then when we create a keeper, we actually can include that in. Of course, it's failing because I don't have it here, but we are going to add it right here. And keeper, and it's going to be expected keepers. Bank keeper. Perfect. And now we are going to add it on the keeper. So it can be used by our functions. So we do here bank keeper, or actually like that. And it's going to be an expected keepers bank keeper. And here we can just do bank keeper BK, and that's it. So now we have access to the bank keeper from our own app. And to make use of it, I'm going to just show an example in new game, just for brevity. So let's say around here, after we create the game, you're going to send the tokens. So we get our keeper, bank keeper dot send coins from account module, and we are gonna do this exactly. This is fine, perfect. And this is also going to return an error, right? So we need to check it, and if there's an error, we're just going to return it. So we are going to send coins from this, from the signer, from the sender, to the module account of our module, and we are going to send this amount. If by any reason the user doesn't have this amount, it's just going to fail, and the entire transaction fails. So now I'm gonna show you the entire thing. And we need to hurry up. Oops, I need to undo this. Perfect. Okay. Okay, now we can see that we are using the bank keeper in two places. So we are using it in the commit move and also in the new game. So if a player creates a game, it sends tokens to the module, and if a player joins the game, it also sends tokens to the module. So right now, well, for brevity's sake, I'm going to tell you that it works. So whenever you create a game or join a game, you're going to get these tokens removed from your balance and sent to the module. And lastly, we're going to talk about the end blocker, because right now we can send the money, but we haven't talked about how the game settles. So to settle the game, we're going to use an end blocker, and the end blocker, it's basically going to go at the end of each block. It's going to go through all the games, and it's going to check if a game has finished, if it has timed out, who's the winner, and all of that, and send out the tokens again using the bank keeper. If there's a draw, of course, it's going to just return the entry fee. So it's going to basically split the price in half. So to see that, I'm going to jump over to the last part, which is this. So we can go ahead and see how an end blocker is defined. So if we go to our module, we can see that we have this function defined here. It's pretty simple. So it's just end block receives a context and returns an error. And we are going to define the actual function inside the keeper so we can access all of the keeper's data and demand keeper and all of that. Something else is that you need to say, hey, this app module struct actually implements this interface. So now we are going to take a look at the actual end blocker pretty fast. There we go. End blocker. So end blocker, it's a bit big, but it basically does this. So it's going to walk through all the games. If the commit timeout has passed, delete the game and refund the entry fee. If both reveals are available, delete the game and pay the winner. And if the reveal timeout has passed, delete the game and pay to the only player that revealed, or if and pay to the only player that revealed. So we are going to use, again, our collections, and we are going to walk through them. We are going to, again, walk through. You can see here that we are walking through the commits of this specific game. So we use the ID here, and we construct a prefix range. So we are going to basically ignore the address part for now, and we are just going to see all of the commits that have this game ID. So we are going to get the players that committed. We're going to check if less than 2 players committed and the timeout commit has passed. We use the bank keeper to return the funds. Well, we do a bunch of checks here also. Well, now we get into the reveal part. So now that we get the reveals, if the timeout hasn't passed and less than 2 players played, we are going to skip this and we are not going to delete it. But if the 2 players actually played or only one revealed, we are going to, and it's after the reveal timeout, we are going to actually continue and delete the game. So we add it to a slice that's going to delete everything later. We calculate the price, which is the entry fee times 2. If only one player revealed, we are going to send everything to the single player. Then we are going to decide the winners. So if we get only one winner, okay, it takes it all. And if we have a draw, we're just going to refund the entry fee. All of these using the bank keeper. And then at the end, we just delete all the completed games. So now that our game is completed, we can finally go to our chain here. And a quick thing that we have to do is that we need to add the module to the list of end blockers, because it's not there by default. So you need to manually add which modules actually have an end blocker, and you need to define the order. So I'm gonna just do this because I have it right. Okay, I don't have it. Okay, we can do it. RPS module name. Perfect. So we are done, and we can install. We are gonna do init, so we remove all of the previous games and tests that we've been doing, and we are gonna set the params for our module here. Perfect. So we can now actually start our game, our chain, well, game chain. Nice. We are gonna check the balances right now. So Alice has a lot of money and Bob just have 1,000 mini. So we're gonna bet 900. So it's gonna be a pretty hard bet for Bob. So we create the game. And now we can check balances again. It takes a little bit until the transaction gets included. Okay, there we go. So Alice already put its part. we can check in the game. We have it. And Bob, it's going to join the game. There we go. We can all again check balances. We'll see that Bob only has 100. Okay, so now I forgot to save the salts, but we can go back here and find them pretty easily. There we go. So now we are going to do the reveal, and we're going to do the reveal for Alice. And you can see there that the reveal timeout already is already set. And we are going to do the same for Bob. There we go. Let's just check just in case that the transaction is okay. There we go. Yeah, code 0. Perfect. So now the end blocker should have kicked in and paid out to Bob and deleted the game because it was defined. So let's see QRPS games. And we see that we have 0 games, but on count, because this is historical and we don't reset it, we know that a game has happened. And if we go to check the balances, we can now see that Bob has a lot of more money than before. So it won the entire pot. So thank you so much. A bunch of things were left out, like testing and other related, but you have here the basics to start building your module and possibly your chain. So I hope you enjoyed it and you got good information from it. And you can check me. You can reach me out on Twitter or GitHub or whatever for anything you need. And I'm gonna post this project on this address in a bit. Right now it's private. I'm gonna post it there after finishing this. So thank you very much.
Thanks a lot, Faku. So yeah, I hope this helps all the builders in starting out strong in the Cosmos Hub and the AEZ Hackathon. But maybe you also want to mention the username that the builders should reach out to you in case of any confusion, doubt, etc.
Perfect. Yeah, you can reach out. We have discussions in the Cosmos SDK, or you can reach me out at Facundo Medica. I'm basically Facundo Medica everywhere, so you can reach me out there.
Perfect. Yeah. Also, in addition to that, if you have any questions about the hackathon in general, feel free to reach out to me at Mishika251 on Twitter or Telegram. But yeah, that was all for today. And with that being said, I would like to thank Longhash, Atom Accelerator, Neutron for facilitating the entire hackathon. And I hope you had a good time. Happy building and breaking. Until the next session or the workshop 2 on 5th September. I'll see you all then. Thank you, Faku. Thank you, everyone, for tuning in.
Thank you. Bye-bye.
Bye.